Recording in progress.
Hello and welcome to my Process Exam 1 screencast. So I'll just jump right in. Question 1B, I had to get values extracted from this graph here. So I used the overshoot, which is A over B, to get a value, and then it's also equal to this function of the squiggle. And then I was able to use Excel Solver to get that. And then I used the period, which is like the time between peaks, to get period, and then use squiggle to get tau. And then I was able to plug that into this. It's a second order transfer function. You can tell from the oscillations. So I plug that into here. K is going to be our change in our output over our change in our input. So based on how much the temperature changed over how much it started, or how much we changed it. To get K, hold on, I just realized I didn't start a timer. Hopefully this is going to be the right amount of time. Okay. Um, and then for C, we did a total mass balance to get like Wi equals W because we have constant holdup, dV/dt is 0, and also our density I assumed is constant. That was an assumption I made. Here we also assumed first order reaction here, so I was able to do a component mass balance as shown here, and then also an energy balance. So it's a lot like one of the homework problems we did. So I linearized it, I introduced deviation variables, I Laplaced it, pretty much just going along with one of my homework problems. And then from there, once I got down to like these really big equations here, I introduced constants and like just grouped everything together that was not deviation variable, everything that was like all of our steady state values. I put those into constants. As you can see, I used like the little Laplace sheet also to Laplace like a dt. And then coming down here, I was able to get Ca prime of s and then t prime of s as functions of w prime of s, t prime of s, and ca prime of s. So I put those all into standard form, as you can tell here. And then from there, once I got all my constants rearranged since it was in standard form, I was able to put it into this giant block diagram. And basically, you can, oh yeah, I have my equations down here. So like CA is going to be a function of a transfer function times the W and then plus the K2 term times the T of S. It's like a loop. It's like a feedback loop. And then also this T prime of S like comes into play. It's like you're adding up this plus this. Yes, so you're adding W times K3 and then plus the CA times the K4 to get the T prime of S, and then we go into the loop law on the in-class explanation of that. I guess to go a little bit deeper onto this, honestly, I think I've covered all my bases. Yeah, this was like this derivation was a lot like a homework problem I was following along with, so it wasn't too bad. It was just like a lot of algebra rearranging and stuff. But yeah, we ended up with the feedback loop, which was what was supposed to happen. So that's good. Moving on to question 2. So I started with the total mass balance. I said like the left side was tank 1, the right side was tank 2. I didn't mind mass balances. I also introduced deviation variables and then Laplace that. Kind of just following the book answer keys, like with their list of things that they did. And then I was able to get to, here we go, we'll follow this left side. We got this H2 prime of S over Wi prime of S. And then over here, like same thing. Basically, we used this tank 2 mass balance to get H1 of S as a function of H2 of S and then plug that in here. So that we didn't have H1 of S in this one. We were able to reduce this down to standard form and then figure out our constants for that. And then I did the exact same thing. I then like used this left-hand side to solve for H2 of S as a function. Wait, what did I do? I used it, so yes, H2 of S as a function of H1 of S, and then I plugged that in to get H1 of S over as how it changes with Wi of S. Okay, so and then same thing, got it into standard form, got all my constants, and then I realized that I forgot to show the pole zero cancellation. So I re-derived H2 of S over Wi of S as this like two transfer functions multiplied, and then I was able to show that, these two will cancel, and that was my pole zero cancellation. I'm not really sure where it happened in my first derivation, but I couldn't spot it. So there it is. It matches my above derivation, so that was great. Moving on. Oh, this is really slow. Okay, trying to go to part B. Okay, so part B was just when there was no weir and super simple total mass balance. I just derived that quickly, and then introduced deviation variables, Laplace it, got it in standard form. It was just K over S. And then I summarized all of my transfer functions down here. So you can see, what am I supposed to talk about for this one? Yes, and then I checked how the surge tank's transfer functions reduced to the normal tank's transfer functions. So down here, basically you can either have A1, so I said our total area A was A1 plus A2. So if I said that A1 was equal to A, then A2 is going to be 0. And then that basically you can plug into these parameter values to get your new parameter values, and then plug in for like G1, because now A1 is A, so like A2 doesn't exist, so you don't have an H2, so G2 doesn't exist. So that gives you the final transfer function of K over S, which is what you should expect if it's just one tank, which is good, so that worked. And then I did the same thing, and I said that like A1 was 0 and A2 was A, so that means I plugged in, got all my constants, and then I used the G2 version of it because A1 is 0, so kind of similarly, H1 doesn't exist because A1 doesn't exist. And then I got the same K over S there. Great. Okay, moving on to our last thing, is going to be this part E. So for this one, it wanted you to graph responses to pulse, pulse changes in WI. So I basically just went through and like Laplace each of my three transfer functions. As you can see, they're like highlighted here. And then for like H1, I figured out like the initial value when t equals 0. I got this value. So like when H1 is 0, it's going to be this value of Km A over A1 plus H1 bar. And then basically, since, well, yeah, you can tell H of t is just going to be H bar plus Km because it's really just K plus H up there. H2 is going to be like approaching 1, I guess, because of this 1 minus e to the negative t. And then it's going to be the opposite for this one because this one's like e to the, well, when you simplify it down, it's like e to the negative t, and then that times -1 kind of. So it's like the opposite of this one, so it's going to be decreasing. And it kind of makes sense conceptually too. So like for H2, since WI, or I guess for H1, since WI enters tank 1 before tank 2, H1's going to jump up and then it's going to decrease. And then the opposite for H2, since it enters tank 1 first, it's going to like slowly increase as tank 1 drains into it and reaches that new steady state. Okay, I think I'm out of time.